every single pair, right? So in this first line, we can see that cow 4 is ranked before cow 1, 4 is before 2, and 4 is before 3. Now we can move on to cow 1, right? 1 is before 2, and 1 is before 3. And then we can look at cow 2. Cow 2 is before 3, right? And so we have these 6 different combinations we've come up with on the first row. And so now we have to go and compare that in the second row. So 4 is still before 1, and 4 is still before 3, and 4 is still before 2. 1 is still before 2, right here, and 1 is still before 3. So that's 1, 2, 3, 4, 5. 5 consistent pairs so far, but the 3 and 2 order is flipped, so we only have 5. We're down from 6 to 5 consistent pairs. Now we can take a look at the last row. So 4 is still before 2, 1, and 3. 4 is still in first place, right? So that's 3 consistent pairs. 2 and 1 are no longer consistent because you can see 1 is before 2 in the first 2 rows. So this is no longer a preserved order. If we look at 1 and 3, 1 is before 3 in every single row. So that gives us our 4th consistent pair. We already established that 2 and 3 are flipped, so that pair is no longer consistent. And so we end up with 4 consistent pairs, right? Cows 1 and 4, 2 and 4, 3 and 4, and 1 and 3. And so let me start annotating. So the general strategy you want to take when you get a problem like this, right, after looking at the sample input, is to kind of create like a kind of general process you think you could use, right? And so what does our intuition tell us? If you were to like try to solve this problem by hand, you would basically try to look at every single number of cows and look at their rankings, right? But the way I see it, like, I think this is a little clunky because the way they give us this input, we have to manually compare each cow's position by looking at the index, right? So what I mean by that is in the sample input, we know that cow 4 is in first place because it's in the very first index, right? Index 0. We know that cow 1 is in second place because it's in index 1. We know cow 2 is in third place because it's third in the row. And we know cow 3 is fourth because it's fourth in the row, right? And the input is basically giving us the rankings of the cow in their positions. But because we have to like compare each of the cow's positions in every single like row, a more convenient way to do this, right? Wouldn't it be more convenient to compare each cow's position by making a 2D array, except this time we make a 2D array with the cow's rankings, right? So over here, this is index 0, right? This is going to be cow 1's ranking. This will be cow 2's ranking. This will be cow 3's ranking. And this will be cow 4's ranking, right? And so why don't we do this? Why don't we create this for the sample input? So in the first row, cow 1 is in second place. So we'll put a 2 here. Cow 2 is in third place. Cow 3 is in fourth place. And cow 4 is in first place. Cow 4 is in first place for all 3 rows, right? So I'll go ahead and put 1. Okay, we can move on to the second row. Cow 1 is in second place again. Cow 2 is in fourth place. And cow 3 is in third place. Okay, what about the last row? Cow 2 is in second place. Cow 1 is in third place. And cow 3 is in fourth place. Okay, so now we have this new 2D array, right? And this is, I'll type it out. We can call this positions, right? So this is our positions 2D array. And this basically gives us the positions of every single cow inside each entry, inside each row. And so this makes it a lot easier for us because now all we have to do is compare each pair of cows. So now we'll start with comparing cow 1, and then we'll compare it to 2, 3, and 4, right? And then we'll get our number of consistent pairs, and then we'll compare cow 2 I can erase. The next step is to compare cow 2 to cows 3 and 4 out of the consistent pairs. And then the last step is to look at cow 3 and compare it to cow 4, right? And this time, because we made it so easy for ourselves, all we need to do when we're comparing two cows is literally look at their respective numbers, right? Because that tells us their place, right? If they're in first, second, third, or fourth place. And if we see that, like, as we go down every single row, if let's say cow 3, right? Cow 3 has a greater number than cow 4 every single row, or if cow 3 it has a number less than cow 4 every single row, then that means that it's a consistent pair, because cow 3 is either always, like higher place than cow 4 or lower place than cow 4. So that's a consistent pair. And so if we just use that same pattern, right? So let me erase. So if we just use the same pattern, right? So we'll starting in this first row, right? We just check cow 1 and then 2, 3, 4, and then like cow 2 with 3 and then 4, and then cow 3 with cow 4. And then do that for the second row and the third row. And we get a number of consistent pairs as we go down. Then by the time we finish looking at all the cow pairs, we'll have our total number of consistent pairs, right? So that's kind of the general concept of this problem. And, obviously there's a bunch of different ways to solve it, but this is one of the more convenient ways to solve it, right? And I think it's like fairly intuitive. So, so we can go ahead and start coding, right? So let me stop my share and let me reshare my screen. Okay. Okay, here we go. So you see I have my Java file here. And I've already done a little bit of preliminary work that you guys should all kind of have set up in your coding file whenever you kind of go into USACO, right? And so here we set up a scanner, right? We have a print writer. So these are input and output writers. And then here I've created 3 variables, right? K, N, and A. And so K is going to be the K in the input. N will be the N from the input. And then I've created the 2D array, which I've just called A for array. Okay, so in our main method, it's the standard setup, right? So you have to create the scanner. So in equals new scanner, new file name. So gymnastics.in. Out is new print writer equals new print writer, new file gymnastics.out. And then create your 2 standard methods, right? That we always use, init and solve. In.close, out.close, make sure you finish everything. And then also remember to throw your exceptions for your main method and also for your init method as well. Okay, so what do we do from here? The first thing to do, right? Wait 1 second. So the first step to do is take in the input, right? So how do we do that? Well, the input is going to be 2 numbers, right? At first, so k equals in.next int. And we also have n, so in.next int. After that, we want to create our A array with all the numbers, right? So A equals new int k n, just like that. Okay, so now here comes the slightly tricky part, right? And I'd say honestly, this is the hardest part of the program. It's how do we create that special 2D array with all of the values inside the array as the rankings of the cows, right? And so, as usual, we do need a double for loop, right? So for int I equals 0, and the first for loop has to go from 0 to k to go down each of the rows. And now the second for loop has to go from 1 to n, right? And I'll explain why in a second. So for int j equals 1, j is less than or equal to n, j plus plus. And then on the inside, this line is going to look like a at I at in.next int minus 1 equals j, right? And let me explain why. If we go back to the, let me share. If we go back to this problem, right? Why don't we just take a look at the sample input? So I'm going to go ahead and draw a 2D array. So one, two, three. And we'll go ahead and label our indices, right? So 0, 0, 0, 0, 1, 2, 3. And so I think the easiest way to look at this is to literally run through the inputs to see what formula it gives us, right? So we want to rearrange these cow lines so that we have the values as rankings, right? So at 0, 0, right? Our number in the input is 4, right? This basically means that we want to go to where cow 4 is as an index. So as an index, cow 4 is like index 3, right? Because indexes start from 0. And so like all the cow 4 rankings are going to be here. And so we see this, we go ahead and we see this 4, and then we say, okay, we want to go to where we put our cow 4 values, which is, in the index 3 column. And then we want to say, okay, because it appears at index 0 inside the input, inside the given input, we know it's in first place, right? So we put a 1 here. Okay, so now we move on to the 1, right? We know that this 1 is cow 1, right? So we look at index 0, right? Because that's where all our cow 1 values go. So I'll say cow 4, go here, cow 1 goes here, right? And then, cow 2 values go here, and cow 3 values go here. Okay. And now we know that because cow 1 appears at index 1 inside this line of input, it must be in second place, which is why we put a 2 here. Looking at cow 2, right? It appears cow 2 means we have to look at index 3. Look at index 1. And then we know that it's in third place. And then cow 3 means we look at index 2, and it's in last place because it's the fourth number to appear. Like that. And then this is the same pattern we use going down the next line. So cow 4 again appears at index 0 in the input line, which means it's in first place. So we put a 1 here. Cow 1 means we look at index 0, and it's in second place. Cow 3 means we look at index 2, and it's in third place. And cow 2 appears in the last index, which means it's in last place. And then finally, for the last line of input, cow 4 means we look at index 3, it's in first place. Cow 2, we look at index 1, and it is in second place. Cow 1, we look at index 0, it's third place. And cow 3, we look at index 2, is fourth place. And so this is how we want to fill out our array, right? And so let me go ahead and go back to the code. So you can kind of see that's exactly what we do over here. So we say for in I equals 0, I to k, right? So we're basically running down the inputs. So we're basically running down each row. We're going from j equals 1 to j equals less than or equal to n, right? That's running through each of these cows in each row. And we're saying a at I, so it makes sense because our array is going to be 2-dimensional. So let me annotate. So right, so that is our 2D array. So a at I, so our i's are going to go this way, right? So by saying at I, we're saying row by row. In.next int minus 1 means that if whatever input they give us, right? So if the first input, let's say, is, we can just take a look, right? The first input is 4, 1, 2, 3. So I'll write that out over here. 4, 1, 2, 3. That means that index int means cal 4. We look at index 3, right? So we're looking at here. We fill it in with j, right? So j is going to be 1. And that's because j will go from 1 to 4, right? Which is literally the order of these cows, right? Like the first cow is in first place, the second cow is in second place, the third cow is in third place, and the fourth cow is in fourth place, right? And so I hope this line makes a little more sense now. We're literally looking at the number they give us inside the array, going to that corresponding cow, and then saying, okay, it's in whatever, it's in that order's place. So since cow 4 came first, it's in first place. And one more, since cow 1 comes second, it must be in second place. And so that's kind of how we're going to fill out our array, right? Okay, so honestly, I think the input is like the hardest part. Everything else after that shouldn't be too difficult. So that's basically it, right? And if we want to test, right, our input, which is always a good choice, we can print out the 2D array like that. And we can go ahead and run this just to see what our code looks like. And you can see we've correctly sorted our 2D array into what we wanted it to be. Okay, so input is done, right? Now let's go to our solve method. So what else do we have to do? Well, now that we've set up our array, we basically just have to count the number of wins that we have, the number of consistent pairs, right? So I'll start by creating the int answer variable. And then we're going to need a double for loop one more time, right? To actually compare all the consistent pairs. So we have our first for loop here, right? And it goes from 0 to n because we have n number of cows, right? So remember, again, we want to compare, like, since we have 4 cows, we want to compare 2 cows at a time. We need one for loop to count, to like go from cow 1, and then cow 2, and then cow 3, and then cow 4. And then we need a second for loop inside that to compare every other cow for each cow in the bigger loop, right? So when I equals 0, we need another loop inside to go to compare I equals 0 to like cows 2, 3, and 4, right? And then so on and so forth. So we need a second for loop inside here that will start from the next cow after I. And so j also goes to n, right? So this is literally just comparing every possible pair of cows. And so inside here, I'm going to create an int variable called win. And I'm going to set it equal to 0. And win is basically just to keep track of like a temporary like, I treat it as like a temporary variable. And so my plan is basically to, if I can redraw this grid one more time, hopefully the last time, right? So we're comparing every possible combination of cows, right? So we're comparing this cow 1 with 2, 3, 4, and then cow 2 with 3 and 4, and then cow 3 with 4, right? These are all of our possible combinations, right? And so each time we compare these pairs, right? When I start with comparing cow 1 and cow 2, I want to go down every single row and check every single row, right? And if this is a consistent pair in every single row, then I can just add 1 to my answer. And then I'll reset answer and then check 1 and 3, right? And then if I'll go down every single row, and then if this is a consistent pair in every single row, then I'll add another one to answer. And that's kind of the procedure we're going to have for checking every single pair. So our win is going to keep track of, is it a consistent pair in each row? And then by the time we reach the bottom row, if it is a consistent pair, our number of rows is equal to our number of wins. That means it's been a consistent pair in every single row, right? And that means that it's an actual consistent, it's a true consistent pair, and we can add it at to our answer variable. So we need one more for loop. And I'll just say m, right? And m has to go to k, right? because k is our number of rows, and then m plus plus. And then here we just have to say if a at m, at I, is less than a at m at j, right? Then we can just add 1 to win. Win plus plus, just like that, right? And then at the very end, after that for loop, if win is equal to k, right? So our number of wins is equal to number of rows, or if win equals 0, because that means that the second cow has been greater ranked than the first cow in every single time, right? And every single row. So the win equals k means that like cow 1 has been greater than cow 2 in every single row, and then win equals 0 means cow 2 has been greater than cow 1 in every single row, right? Then we just add 1 to answer, just like that. And then at the very end, at the very end, we just have to print our answer to the output file, like that. And so this will basically give us a code. And just to go over this if statement here, so this m for loop is going to run through each of our rows, right? That's why it goes from 0 to k, because there's k rows. This if statement is checking if m at I basically means like cow 1, and then m at j will mean cows 2, 3, 4. And then it's basically, that's going to go down every single line, right? So if we're comparing cows 1 and 2, then we'll compare cows as m increases to k, we'll check cows 1 and 2 down every single row. And then j will increase, and then we'll check cows 1 and 3 down every single row for because of the m loop. And then we'll do cows 1 and 4. And then we'll move to, and then I will increase by 1. And so we'll check cows 2 and 3 down every single row, so on and so forth. So that's basically the code to this problem. I will go ahead and upload it to the website just so we can see. So let me clear all my annotations and then go ahead and upload this. So let's see. And I'll reshare this. Okay, so yeah, that's basically the code for cow gymnastics. I hope that made it a little easier to understand. Okay, so the next problem. Where am I? So I'll go ahead and read the problem. Farmer John has gone out for a walk down the road and thinks he may now be lost. Along the road, there are n farms, and n can be from 1 to 100. So there are n farms in a row. Farms, unfortunately, do not have house numbers, making it hard for Farmer John to figure out his location along the road. However, each farm does have a colorful mailbox along the side of the road. So Farmer John hopes that if he looks at the colors of the mailboxes nearest to him, he can uniquely determine where he is. Each mailbox color is specified by a letter in the range A to Z. So the sequence of n mailboxes down the road can be represented by a string of length n, right, from 0 to 100, containing from 1 to 100, containing letters in the range A to Z. Some mailboxes may have the same colors as other mailboxes. Farmer John wants to know what is the smallest value of k, such that if he looks at any sequence of k consecutive mailboxes, he can uniquely determine the location of that sequence along the road. Okay, so for example, suppose the sequence of mailboxes is A, B, C, D, A, B, C. Farmer John cannot set k equal to 3 because if he sees ABC, there's 2 possible places ABC could be, right? And so he's still not going to know where he is. The smallest value of k that works is k equals 4. Since if he looks at any consecutive set of 4 mailboxes, right, ABCD, BCDA, CDBA, or DABC, the sequence of colors uniquely determines his position along the road. Okay. So the input, the file will be whereami.in, and the output will be whereami.out. So for the input, the first line of input contains n, which is the number from 0 to 100, from 1 to 100, and the second line contains the string of n characters, and every character will be a letter ranging from A to Z. And the output will be printing a line containing a single integer specifying the smallest value of k that solves Farmer John's problem. Okay, so this sample input, they've already explained. So it's a string of length 7, and we know that the smallest unique subset is going to be of length 4 in order for Farmer John to figure out where he is. Okay, so when I read this problem, the first thing I automatically think is like, and I think a general strategy you should have going into every problem is like, once you understand the problem, figure out first what they're trying to test you on, what concept they're trying to test you on, right? And so here, right, if we get rid of all like the junk, right, about the paints and the colors and Farmer John, right, they're basically going to give us some string of this length, and they want us to find the smallest unique subset, basically, of characters. And so, like, how do we do that, right? And, you know, whatever, let me go ahead and annotate. So you can have whatever string, right? I'm just going to type a bunch of letters out. Oh, it's not a letter. Right? So let's say we have this random string here. No matter how long a string is or what letters it has, all you have to do, right? What is one surefire way of determining whether the subset you have is the minimum subset, the minimum unique subset, right? So how can you guarantee that whatever section of letters you're looking at is unique? And what automatically pops into mind for me is unique means appearing once, right? Okay, so what about CD for the example? That's a unique subset. Yeah, that's a good question. Hang on. So CD is a unique subset. Yeah, so let's see. We want to know. Okay, yeah, so I guess I like phrased it a little wrong. It's not necessarily the smallest unique subset. I guess I don't really know what it's called, but we're essentially looking for the smallest like range of letters so that it's like unique, right? It's unique in the string. Not really sure what that's called. I thought it was called like smallest unique subset, but it's honestly whatever. So you're talking about an example, right? Like CD is a unique subset. You're not looking for I should rephrase. You're not looking for the smallest unique subset. You're looking for the size of the smallest unique subset, right? So you brought up a good point. What about CD? Well, CD is unique, right? There's no other CD in the string. But we're not looking for this. We're not looking for the actual like subset letters. We're looking at the size. So if you say CD, that's size 2, right? And unfortunately, size 2 does not contain unique subsets because there's like AB that appears twice, BC that appears twice, right? And so it's like, what size does your smallest unique subset have to be so that every subset is unique, or like every subset of that size is unique, right? If that makes a little more sense. And so we're looking at the sizes basically. And so how can we guarantee that this size of the subset is going to be unique, right? And so to me, what automatically pops in mind is we just have to check if this size, only this size like of this substring that we're looking at only appears once within this entire string, right? Because if it does only appear once, then that means it's unique. Okay, so that should make pretty intuitive sense, right? It's unique if it only appears once. So how do we go ahead and translate that into like Java code, right? And to me, like if you want to check if something appears once, you just have to check for the first time it appears, right? And you just have to check for the last time it appears. And then if those two things happen in the exact same place, then you know it's only appeared once, right? And so you know that that's a unique subset. And just building off of this logic, right? What happens if, let's say you're checking for the first time it appears, and it appears here, and you're checking for the last time it appears, and it appears like here, right? So they're not the same. Then you know that this subset, the subset of this length appears more than once, right? So this could be like ABC, and this could be like ABC, right? And you know that this is not a valid solution. Okay, so let's get into coding this. So let me go ahead and reshare Eclipse. Okay. And okay, perfect. So this is where we want to be. Okay, so again, I've done a little preliminary work. I've created my scanner, my print writer, and I've created an int n and a string s, right? Because that's how they're going to give us the input. Okay, so make sure you throw your exceptions for both your methods, right? Standard, same creation for scanner and print writer. In equals new scanner, new file, file name. Out equals new print writer, new file, file name. Init solve, init close, out close. Make sure you finish everything. Okay, so in our init, right, the first thing we want to do is actually take in the input. So we'll say n equals in.next. We'll also say s equals in.next. You can say in.next line. It doesn't really matter. The point is we now have our n and our s, right? And yeah, there we go. And that's basically our init. That's all it is, right? So now we go to our solve. And what do we want to do in our solve? Well, we basically want to go ahead and run through the entire string to check if every substring we're checking of every length has is unique, right? So we'll create an answer variable, and this is going to be the number we return, right? We're also going to want a Boolean to check if the thing that we're looking at is unique or not, right? So I'll just name it like okay, like is this okay or not? We'll say it's true. Okay, so now we need our double for loop to run through the entire string. So this one will start from 1 and go to n, right? And this is going to run through the string. We also need one that starts from 0. So I'll just say j, right? And j is going to be less than or equal to n minus I and j plus plus. And so why did I set up my for loops this way? Well, it's because this outer for loop, this I loop, is going to be, let me go ahead and create some text. Or I'm just going to draw some gibberish, right? Like, we'll just say these are all letters, right? Even though these are clearly not letters, right? So this is going to be our I, right? And our J loop is basically going to give us the string, the substring length that we're checking. And so like this combination of I and J is basically going to have us check every single length of, basically every single length of substring from every starting point, right? Just like that. Oh, so let me rephrase that. It's actually the other way around, right? So let's say these are all letters. So our J is actually going to be our starting point. So J is going to be 0 at first, and then I is 1. So we're going to check every, like just basically every character, right? And then J is next going to, let me go ahead and erase this. Next, when I equals 2, right? J is going to start here. J is still going to start here, right? But now we're checking length 2. So we're checking these, then we're checking these, then we're checking these, then we're checking these. And then when I is length 3, we're going to check these, and then these, and then these, and so on and so forth. And then let's say we finish all the J's, all the I's here, all the J's here. We're going to move on So then we're gonna start here. Oh yeah, you get my point. So we're gonna run through every single combination. So that's the point of this double for loop here. Okay, so we need to actually like create a string to save the substring that we're looking at, right? So we don't have to call it again every time. So I'll call it temp. We'll say temp equals s dot substring, right? And from what to what? It's going to be from j to j plus I, because j is our starting index, and I is a length, so j plus I will be the ending index of the substring that we're looking at. Okay, so now we just have to use a for loop to go ahead and check if it's unique. Sorry, not a for loop, an if statement, right? We just have to check if it's unique. And we already said that we can check if something is unique by saying if it only appears once in a string, aka we can check if it appears once by checking to see if the first time it appears is the same index as the last time it appears. And so we can literally just use the index of, right? If s dot index of temp is not equal to s dot last index of temp, right? Well, then this means that the starting index and the last index are not the same. So this substring appears more than once in a string, right? So that means that this substring is not okay. So we set okay to false, right? So we start okay at true, and then it's like innocent until proven guilty. So we get proven guilty right here. So we set okay equal to false, and then we break out of this inner for loop because we can go ahead and check the next. We can go ahead and increase I and then check the next length of all substrings, right? So if I equals 1 and then we break, then we can now move on to I equals 2 because we know that I equals 1 is not going to work anymore, right? Okay. So once we finish this J loop, this inner J loop, that means that we've checked literally every single substring of length 1, let's say, right? Whatever I equals, so length 1 inside the string. And if we made it this far, that means we have not broken out, which means that this works, right? It's okay. And so if we're okay, right? If we've gotten up to this point, we can just say we can set answer equal to I, because as of now, up to this point, as far as we know, I is our answer until I can get bigger, right? And then we can just break out of here. And then we just have to set okay to true. And so this if statement is basically saying if this string is okay, if this length is okay, then this is our answer, right? And then we can just break out. If it's not okay, right, then we reset okay to true, and then we go ahead and increase I by 1 and continue checking the string, right? So like if when I equals 1 and we get here, then we say okay is true, and then we check we set I equals 2, and then we restart everything. Okay, and then at the very end, all we have to do is output the answer, just like that. Okay, and so this should work. Let's go ahead and run it to save it. And I will go ahead and upload this into the website just so we can see. So let me share my screen. Here we go. Okay. Okay, so as you can see, so that is one possible solution of the 2nd December contest 2019 bronze for my problem. And so if you have any questions, you can go ahead and ask. I'd honestly suggest that like the best thing to do is like whenever you get a USACO problem, right? You don't have to like learn any super complicated algorithms. For bronze, you like there's really no point in like trying to make like optimize a program. As long as it like works, it's fine. Like, and so whenever you read first go ahead and read the problem, and then work through the sample input, right? And figure out how you're doing it as a human, how you're like thinking of solving the problem as a human. And then once you do that, figure out like kind of systemize it, right? Systemize your approach and figure out how can we translate what I'm thinking in my brain to like code, right? To like a series of steps, right? So turn it into a series of steps. And like most of the time, the way your gut tells you how to solve the problem is going to be the right way to do it, right? So going back to this first USACO problem, it was like, how would you solve this as a human, right? Looking at the sample input. Well, if you yourself had to calculate the number of consistent pairs, you literally want to see, okay, is cow A before cow B in every single row? And how do you look at whether something is before something else, right? You're like, okay, this one's first place, this one's second place, this one's third place. And so we can go ahead and create an array of places that makes it a lot easier to compare, right? Okay, so, we just have to go down every single row and just check to make sure that in every single row, this cow has a number smaller than this other cow, or this cow has a bigger number than this other cow in every single row. And so you can go ahead, and it's the same thing for here, right? And so just try to create a series of steps. And then, at the very end, it's try to translate that into your code. And that can be kind of challenging sometimes. For example, like the code for, let me go ahead and share my screen. Like here, this isn't like the easiest to understand at first, right? This line right here. But once you like work through the sample input and you figure out like, okay, how are we going to rearrange the numbers so that we put the rank values inside each cow's position, it becomes a lot easier to understand like why this works, how this works. And when I used to do these problems, I remember I would literally like hand draw the problem and write out. Like I would honestly have probably like written out this line as I was like solving the sample input by hand, and then just like copied it into the code because I've already like figured it out by then, right? So it's honestly just like making it as simple and intuitive for you as possible, right? Because all of you guys can get through Browns. So is there a solution with a faster type complexity for this problem? I'm sure there could be, right? So right now, we have like what, O of n squared, because we have two nested for loops. I'm not really sure. Maybe there is like, n log n or something. I honestly have no clue. But as far as we're concerned, it's not really what we need, right, in order to solve this problem. If you can find one, that'd be pretty cool. And so yeah, when you guys work on these problems, just try to remember that. It's honestly all I have for today. So thank you guys so much for coming. And I'll see you guys next time. Yeah, thank you. Alex, Sophie, you guys can go, or you might not be here, so I'll just. Oh, well, I can't kick you, but class is over, guys. So, yeah.